right, hi everyone, I'm Adam from Johns Hopkins University, and I'm going to tell you about a new type of neural architecture that is much more robust to partial occlusion than standard deep neural nets. So we've conducted a number of experiments to actually show the sensitivity of deep networks to partial occlusion. For example, in this experiment, we train neural networks on non-occluded images, and then we test to classify on increasing amounts of partial occlusion. And as you can see, the more partial occlusion we add at test time, the more significant actually the performance drops. So we've conducted a number of other experiments that also show that even if you train deep nets with partial occlusion, if the occluders are biased in terms of their position or appearance, deep nets cannot generalize. So this seems to be a really fundamental problem of deep nets. Now we have this really nice model that is highly discriminative but not so robust to partial occlusion. But we know actually that compositional part-based models that really represent an object in terms of like a spatial composition of parts work very well under occlusion. However, they have a problem with discriminative performance. So they are not as discriminative as deep nets. Now what we want to do here in this work is to really combine the best of both worlds into a new type of model. Now let me explain you our main idea. So what you see here is a schematic illustration of a neural network. You have the input image, a few convolutional layers, and then a classifier on top. Now, our main contribution is really to get rid of this fully connected classifier and replace it with a generative model of the neural feature activations after the last convolutional layer. So what you can see here from this model is that we really represent the feature tensor, the 3D feature tensor, as a spatial composition of individual feature vectors. Now, what will happen when an object is occluded is that the activation pattern in those feature vectors will be very different from when it's not occluded, right? So what we can do is we can use an outlier model and this generative object model to actually detect those and get rid of those for classification. And actually that's what I'm showing on the next slide. Yes, this is the log likelihood ratio between the outlier model and our object model. So whenever this is positive, actually our model thinks the object is occluded. So what you can see here is all of the occluders, despite having really different shape and appearance, can be localized quite well with this very simple mechanism. And this really enables our compositional model to generalize really well under partial occlusion. And that's what you see on the next slide. So that's the same experiment, and you see that actually it outperforms the standard deep network under strong occlusion a lot. However, it's not as discriminative for non-occluded images. Combine the outputs of those models to get like a really robust and highly discriminative model.